welcome back to our channel. Today we are going to explain you how to find out voltage regulation of this alternator rated for 400 volts, 4.33 amperes current, and we are going to find out the voltage regulation of an alternator using an ZPF load. Okay, so here we have the ZPF load. This is nothing but zero power factor load, where is called zero power factor load is nothing but inductive load. Why? Because cos phi is equal to 0 and phi is equal to cos inverse of 90. We are going to get it as a 90 degrees. So the voltage and current are segregated by 90 degrees. This is nothing but a variable inductive load. Now we are going to find out the voltage regulation of an alternator using ZPF method, zero power factor method, and we are going to determine the ZPF characteristics of an alternator, and we are going to find out the regulation by Portier method. Let's try to see the circuit diagram. So already it is explained in MMF method also. You have an DC motor. So this is nothing but the DC motor. So to this DC motor, so this is completely a DC shunt motor. This is completely an alternator. In this DC motor, you are going to have two types of winding. So one is a stator part and next one is rotor part. On the stator part, you are going to have field winding, and the rotor part you are going to have armature winding. It is reverse in the case of an alternator. So here you have rotor part and here you have stator part. On rotor part you are going to have the field winding, on the stator part you are going to have an armature winding, and this armature windings is brought out as R by B. Now let us try to see the connections, how to connect this ZPF method. So when you come here, so the positive terminal is connected to the 3-point starter, and from the Z is connected to an field rheostat. Output of the field rheostat we are connecting to the field winding. So from the 3-point starter we are connecting to the armature rheostat. Output of the armature rheostat we are going to connect to the armature winding. That's how this complete setup acts like an prime mover. Now already I told this is an alternator. We need to excite it. So you have an stator. There the stator is nothing but a field winding. So this is the circuit how to excite the rotor part. So how to excite the rotor part is with the help of an DC supply. So coming to the excitation system, we have a DC supply. From the positive we are connecting to the one end of the potential divider, from the negative we are connecting to the another end of the potential divider, and output of the potential divider we are connecting to an ammeter, and output of the ammeter we are going to connect to the field winding of the alternator. And now supply is generated, AC supply is generated from this alternator across R, Y, B, and we are connected one bulb and an 3-phase switch. Okay, now let's try to check out how to do this experiment. Okay, so the procedure of starting this experiment is first we need to excite the prime mover. So how to excite the prime mover is with the help of an DC shunt motor. Okay, so I will show you the connections how to excite the DC shunt motor, and I will show the connections of how to excite the field winding, the rotor part of an alternator, and will show in detail such a way that you can understand. So as per the given circuit diagram, here we are going to have, this is called the DC shunt motor connection. So from positive we are connected to the line, and from Z we are connected to the input of the field rheostat. Output of the field rheostat we are connected to the field winding, and ZZ we are short circuiting as per the circuit of field winding. So field winding current is low, we are using an thin wire. Now coming to the ammeter, armature winding. So from the armature 3-point starter we are connected to the lower end of the rheostat, and the variable terminal of the rheostat we are connected to the armature winding, and AA we are going to connect to the negative. So this how will act like an prime mover. So this is we connected the prime mover part. So successfully we connected the connections for prime mover part of an 3-phase alternator. So now coming to the next one. Now we need to connect the excitation. So here we have the rotor. So here rotor is nothing but made up of field winding. Now we have to excite the field winding. So coming to the connections. So here we are having a positive wire. So from the positive of this DC supply, we connected to the one end of the potential divider, and from negative we are connected to the another end of the potential divider. From the variable terminal we are connected to an ammeter input, and output of the ammeter we have been connected to the field winding of the rotor, and XX we have been short circuited, where this forms an closed path. To measure what is the voltage is really available, I have been connected an bulb and this is also connected to an, so you can see this voltmeter is connected between, so this voltmeter we are going to connect, so the negative is connected to 1y, and R we have been connected to the R and Y, we connected the voltmeter which measures line voltage, and from RYB we have taken 3 wires. This is RYB, and we are going to close the switch and we are going to apply the load. Now let us try to see how to measure the voltage regulation of this alternator using an ZPF method, and how to find out the ZPF characteristics of this alternator, and how to predetermine the regulation of this by using Portier method. So now the procedure of starting this experiment is, so here we are going to apply long